So hello aspirants, welcome back to this channel, and this is another video of this session of what we are doing, that 1000 questions we will continue. Okay, and this is again from your 2021. You are having a question in front of you. This question is very easy, but this question is having like from organic chemistry class 11 and 12, both the concept is needed for it. Okay, so the first thing that is given is that a molecule like this. A molecule like this is given, and in this molecule, it is given Zn8C, concentrated 8C. Now, this reaction is very easy if you know what is this reagent, right? So, this reagent is very famous and it's a name reaction. This is called Clemenson reaction. This is called Clemenson reaction. So, what is the utilization of this Clemenson reaction? Let's first discuss about this. Suppose if you are having a double bond O group, like this, that means if you are having a carbonyl group, it reduces the carbonyl groups, okay? It reduces the carbonyl groups to CH2. This is the utility of Clemenson reaction. Now, there are two reactions possible for this. One is zinc amalgam concentrated HCl. This is called Clemenson, as we have discussed, okay? This is called Clemenson reaction. And there is another reaction. Which reaction? Can you tell me? There are another reaction which is doing the same thing, that this carbonyl group will be converted to CH2. Yes, right. The reaction is called Wolff-Kishner reaction, right? Wolff-Kishner reaction. Okay. But the thing is that we will do question with this also. This Clemenson reaction is in acidic medium. This Clemenson reaction is in acidic medium. This Wolff-Kishner reaction is in basic medium. Okay. So it depends what is your starting material, and depending upon them, you have to choose if you want to do it in acidic media or if you want to do it in basic media. If you want to do it by Clemenson reaction or you want to do it by Wolff-Kishner reaction. So for here, it is given Clemenson reaction. So we'll do. So what is the thing? What is happening here? This is your carbonyl group, and that will be converted to CH2. Everywhere the reaction is same. It's a super easy reaction, but it's important also. Okay. So it will be like this, and now this CO group has been converted to CH2. Right? Now, how many carbon you are having? Sir, I am having 1, 2, 3, 4, 5, 6 carbon with a methyl. Okay. Now, this second reaction, this is actually from class 11. Well, now, somebody of some, like most of you are having like class 11, there is the weakest part, right? But Cr2O3 and this temperature, that is, this is 6, this is 500 degree temperature, right? 500 degree temperature. This reaction we have to know. Now, what is this reaction? This reaction is, suppose if you are having a hexane ring, N-hexane ring, suppose you are having. In this N-hexane ring, suppose if you do Cr2O3, or you do MO2O3, or you do V2O5, then there is a reaction happening that is called aromatization. This is the important reaction, aromatization. What happens that 1, 2, 3, 4, 5, 6. 6-member chain you are having, 6-member chain you are having. You are having a 6-member cyclic aromatic molecule. That means you can form benzene by this reaction. That's why you are forming an aromatic ring. That's why it's called aromatization reaction. Now, this reaction is important. Why? Because this is the aliphatic compound. This is the aliphatic compound. And what you are producing is an aromatic compound, right? Now, you can do so many name reactions that they are in your syllabus, but you cannot find any single reaction where aliphatic to aromatic this thing is happening. That's why this reaction is important. Okay. So this is for our learning purpose. Now, what is given here? You see, it is given 6 carbon is given, but with this carbon number 3, you are having a methyl group. You are having a methyl group. No, not methyl. Actually, you are having a ethyl, right? You are having a ethyl. So if you are having a ethyl group, then what will happen? 1, 2, 3, 4, 5, 6. And with this third carbon, you are having this group. And if you react this with Cr2O3 or MO2O3, what will happen? You will again get a 6-member ring, no problem. But this is now becoming your substitute. That means like this. So it is nothing but benzene ring with a ethyl group, CH2, CH3. The name of this is ethyl benzene, right? Ethyl benzene will be your product. So, sir, what is my product? The product you are having is option number A is matched very quickly. That will be your answer. Okay? So, this is a very good question, right? Now, go for the next question. And this question, what you have to do is that you have to make this molecule. Okay? You have to make this molecule. This molecule you have to make. So, CH2, CH3, and at the meta position, you are having chlorine. This is very important. So, what you have to make is beta-chloroethyl benzene. You have to make beta-chloroethyl benzene. And for that, they are given you 4 options. 1, A, B, and C, and the rest is all of the correct. Now, you have to tell me that which reaction is correct. Now, here the play will be, thing that we have to look is that meta directing group I have to take. So, if I take the, suppose if I take the first reaction, that means the benzene ring is given, and with this benzene ring, it has been reacted with CH3, CH2, CH, and anhydrous AlCl. Of course, I know that this is a Friedel-Crafts reaction, right? Friedel-Crafts alkylation. And as it is, there will be no rearrangement and all these things, this Cl will be taken by this AlCl3. Okay, AlCl3 is acting as an weak acid. All these things we will learn. Okay, when we will do mechanism, we will learn all these things. Now, basically, you are having a CH2, CH3. That means the group you are having now, the group you are having is a alkyl group. It's an alkyl group. And what effect alkyl group have? This is showing plus I effect. This is showing plus I effect. Plus I effect means electron pushing effect by induction. Electron pushing effect by induction. So as it is pushing electron, that means it is a activating group. I hope you know all of this. If you don't, you please revert back to me. I will make you understand. This is called a activating group. Activating groups means it's the orthopara directing group. It's the orthopara directing group. So this many information you have to know. You have to know the basics of this. Okay. So that means if you take this ethyl benzene and if you do the chlorination, and for chlorination you can use Cl2FeCl3. This is a reagent for chlorination and it's an aromatic electrophilic substitution. I hope you know all of this. Then what happens? You will get CH2CH3, I'm writing ET. You will get a chlorine here, or you are getting a chlorine at the ortho position. Obviously, this will be your major product and this will be your minor product. But you don't want this, do you? You don't need this. You need this molecule. That means you need the chlorine at the chloro position. Why you are not getting this? Because this molecule is a orthopara directing group. This molecule is the orthopara directing group. So whatever reaction you do, you will always end up with the para substitution or ortho substitution. Now you can say that, okay, sir, I will do the opposite thing. I will first react, I will first add chlorine, then I will add. But no, that is also not possible. But we'll try. So if I try first Cl2FeCl, then I will first do chlorination. Now I will get Cl, chlorobenzene, no problem. Now, sir, what is the effect this chlorine is? Now, these halogens are having some unique effect. It is showing minus I effect and it is showing plus I effect. Sir, why? Because you see chlorobenzene, if you write chlorobenzene, then what will happen? This can give electron like this. It can do resonance. But this resonance is not so effective because it's at 2p, 3p overlap. But it can also take electron like this also. It can also, as it is halogen, it is the electronegative, so it can take electron by minus I effect. It can give electron by plus I effect. And for halogens, it is most important that minus I effect is predominating over plus I effect. This is generally not possible. Always resonance predominates. But here, minus I effect is predominating over plus I effect. Why this is so? Because here 2p 3p overlapping is happening. In case of resonance, that is not so effective. Okay, that means minus I is predominating over plus R, means it is neatly electron withdrawing. It is neatly electron withdrawing. Okay, sir, if it is electron withdrawing, that means it's a deactivating group, right? Yes, it's a deactivating. But as it is giving electron at this minus, at this ortho para, and this ortho position by resonance, so it's a deactivating group, but it's a ortho para directing group. So this is the exception the halogens are having, because their minus I effect is predominating over plus I effect. So they are neatly deactivating, but they are ortho para directing. Okay, sir, if they are ortho para directing, then I cannot do the reaction, right? Yes. So your reaction, you cannot be successful by this process. If you add CH3CH to Cl and anhydrous AlCl3, that means if you do Friedel-Crafts alkylation right now, if you do Friedel-Crafts alkylation, again, you will end up with chlorine having Et here and chlorine having Et here. Got it? You cannot get the meta. Obviously, this is your mirror and this is your minor. But what you want is the meta product you can. So, sir, what is the last thing we are having? So, the last thing we are having is that we have to do Friedel-Crafts acylation. That means we have to do CH3C double bond OCl anhydrous AlCl3. If I do, it is called Friedel-Crafts acylation reaction. In this Friedel-Crafts acylation reaction, what is happening is a benzene ring, you will get C double bond O CH3, and the beautiful thing that's happening is that it can do resonance, and it can do resonance like this, and you will get a plus charge like this. If I do the resonance, you will get a positive charge like this, plus here like this, and you can do the resonance, continue the resonance. That means you are getting a benzene ring where you are getting plus charge here, plus charge here, plus charge here, like that. That means what you are having is that your ortho, meta, ortho and para position are actually deactivated. So it's the deactivating group and it's a meta directing group, right? I will take a session only based on this thing. What is ortho para, what is meta directing, all this thing. But it's a meta directing group because here minus R effect is operating. Okay? Minus R effect is operating. So if this is the case, and if you react this benzene ring with C double bond O CH3, then you do Cl to FCl3, okay? Then obviously your Cl will come in the meta position. There is no other way. It has to come in the meta position. But sir, I don't want this. I want CH to CH3. Yes, you can get your CH to CH3. And in the first question only, we have done that Zn8 is concentrated HCl. If I use this, CO group will become CH to CH3. And what is this name reaction? This name reaction is called, tell me, what is this name reaction? This is called dimension reduction. This is called dimension reduction. So by this way, you have to do this. So you need 3 steps. First step is that from benzene ring, you have to make C double bond O CH3. Then you have to add chlorine, because now your chlorine will be added at the meta position, right? And then you have to change your COCH3 group to CH to CH3 group. And for that, you have to do dimension reduction. Got it? So this is the ultimate process. So is it given? Let me check. Yes, obviously it is given in option number C, and that will be your answer. So C will be your answer here, and A is the answer. Which question we are supposed to do? Yes, and A is the answer here. Okay, so this is the step where we have done first. We have done dimension reduction, And secondly, we have done aromatization. And this reaction is important. Okay. And second question we have done is the sequence of reaction. This question is based on sequence of reaction. Sequence of reaction. Which reaction you have to do at which position. Okay. This is a very good question. And this is all that from previous year's question series. And I hope you like this. And if you are having any, like this question is one of the students have asked me, that's why I put this question. Okay. And if you have any question, any problem regarding anything, you can ask me. So I'll try to answer the question. And also try to do this question by your own first and then see the video. Okay. First pause the video. Try to do the question. If you are not getting the answer, then you see the video. And after 1 week also try this question again if you can do this question or not. Okay. And these are all previous year questions. And this previous year question, if you can do, if you are able to do this, it will give you immense confidence. Okay. That yes, I can solve this type of questions. Okay. So yes, I hope you like this session. And like if you are having any problem, you can ask me in the comment box. Always. And bye. Okay. Thank you. Thank you.